now start talking about what? Solving the question, applying the theorem in order to what? To deal with what? With circles, as well as to draw a relationship between these two theorems, as well as what? As the first theorem which we did in the last class. Suppose I have a circle like this with the center here. Now, the theorem I want to talk about how to find angle in a semicircle. You know very well from the basic geometry class, that basic class in geometry, that finding a semicircle simply means to cut a circle into two equal parts. And this circle can only be cut into two equal parts by the use of what? A line, which passes through what? The center of this circle, and at the same time we touch one point here as well as another point here. And the name we give to this line that passes through the center and as well meets the circumference of the circle at the two different positions that are opposite to each, that faces each other. So it's what we call what? A diameter. So we call that line what? A diameter. So it is this diameter that divides a circle, a given circle, into two equal parts. Now what we are interested in now is how do we find angle in this diameter? That is, how do we determine angle that are resting or that is resting on this semicircle? Alternatively, we can state it by saying that what? How do we find angle in semicircle? So when I say semicircle, it means I'm interested in what? Only parts. You know, since we're having two parts, so we're interested in one of the two parts. So what that simply means is, if I have opportunity of covering this thing, so what I need now is, how do I find angle that is on this semicircle which I have here? Or it is possible I cover it from above here, and I'm interested in what? Looking for the angle in this what? Semicircle that I have here. So to doing that, two things is required. So those two things that are required is this. So first of all, we have to do what? We go to the two endpoints of this line called the diameter. So we can see this is one endpoint. We can call this point A. This is another endpoint which we can refer to as what? As point B. Now, to forming an angle at the circumference. So remember I made mention of it in the last class that what we mean by circumference simply means any parts of what? Any traces that make what we call what? A circle. Even if it is a semicircle, so when I form angle at this point, any given point on this trace here is what we simply mean by what? What we simply mean by what? A circumference. So we want these two lines here to be joined together here at somewhere in here in the circumference of this circle we have here. And to doing that, what we are going to do is we go to the endpoint A here, we keep moving, a straight movement until we are able to hit circumference of the circle. So one of the way I can do that is I can move like this, like this, like this, like this. So since I've hit this area here, this is the stopping point. Now the second requirement is I will have to go to the end point of my diameter. Remember the diameter that breaks this given circle into what? Into semicircle, that is into two equal semicircles. So as a result, it is the end point of the diameter, the end point of this line, that will determine angle on this semicircle. So to forming the other one, what we want to do is we want to move from this end here. We'll keep moving, we maintain a straight line in such a way that it has to what? Join this point here. Suppose this point is C. So we want the movement from this point B to come and join the point C, which we obtain when we moved from A to somewhere on the circumference. So to doing that, so we can see the movement has to be like this. It has to be like this. So we can see the two join at this point Z or C, or where we can call the vertex of what? Of the shape that I have here. Now the distance between, space between this line as well as this line here is what we call, is an angle. And the name of that angle is what we call angle in a semicircle. Now let's also make use of another diagram. Suppose I have this diagram. This is my center, and the diameter is drawn in this manner. This is the way by which the diameter is drawn. So this is center O. Center we usually call it O. Suppose this end point here is P. Why this is endpoint Q, and I'm interested in what? Forming angle in semicircle. So to form an angle in semicircle, it can be done in two ways. either to this side or to this side. But suppose I want it to be in this area. So two things is required. The first thing is I will have to go to the two endpoints of my diameter that I have here. So then from the first endpoint here, or any of the two can be called our first endpoint. So from any of the two endpoints here, what I want to do is I want to keep a straight movement until I hit or I touch the circumference of the circle. So to doing that, so I can move like this. And the next requirement is I also have to go to the other endpoint of what? This are diameter, and I will also keep a straight movement, but this time around the movement, the line I want to draw must what? Must touch this place so as to form what an angle. Remember, we want to form an angle. So in order for us to form an angle, it means moving from here we have to touch this place. So distance between these two lines is what now gives what? An angle. And the name we give to such an angle we are going to form is what we call what? Angle in the semicircle. So to doing that, we just move like this. So we can see this is the angle. It's the two movements produces. So this is what also what we call what? Angle in what? In semicircle. And suppose we call this place R. So the value of angle R is what we have here. And in some other situation, a value will be given there. So let's assume the value of our angle here is better. So these are the very basic thing that one is to know. Once one is able to know, how do we define angle in semicircle geometrically or diagrammatically like this? It will now be very easy for one to be able to do what? To deal with questions as well as what? To solve questions. So that is the first aspect of what we want to talk about today. Now the next aspect of it is to also discuss what we call angles in the same segment, and how can we identify any two or more angles that happens to what? To fall in the same segment. So to be able to do that, let's also make use of what? Of a circle like this. Suppose this is the center, and I have something like this. Something like this. The diagram is somewhere here. Now, suppose I have something like this, and as well I have something like this. So it can come in this manner. Suppose this is O, this is A, this is B, this is C, and this is what? This is D. Now, what we want to do now is to identify what are angles that are on the same segment. So in order to determine an angle on the same segment, what we have to do is we are going to pick a particular angle. So what we want to do with that angle is we want to know what is its base. So suppose I pick this angle. So this angle, what I will first of all do is I will convert this angle into what? A triangle. So suppose this is a triangle. So we can see the angle here. This angle is this. So the vertex. So from this vertex, we want to know the base of this angle. So in order for us to be able to know the base of this angle, so what that simply means is what? We convert the diagram we have here into what? Into a triangle. So when we convert it to a triangle, the base, this place upon which this thing is resting, must be what? Must be a chord in the diagram which we are given. So what we now need is we need any other angle that has this chord as its own base. So any two or more angles that have common chord, common base is what we call angle in the same segment. So to be able to do this one, suppose I have picked this angle D here. So in order to make it a triangle, so what it means is we can see this line here, this angle here. So two lines that form this angle for us are the line that moves this way and the line that moves this way. So we can see that the base, suppose this place is top of the angle here, so this place is going to be the base of the angle as well as this place. Base of this line is this, while this place is the base of the other line I have here. So what I will now do is I will try and join the two bases together. The two bases, I will join them together. So when I join them together, it's going to give me a chord upon which this angle D we are having here is resting. So to doing that, I can do it like this. It can be like this. So we can see that angle D here has AB as its what? As its chord. It is resting on chord AB. Now to not talk about angle in the same segment means we need any other angle Now, when we talk about angle in the same segment, it is basically referring to angle in the circumference. It can't be angle in the center. It only means angle in the circumference. So what we need now is, we need another angle in the circumference that is resting on this called AB. That is what we simply mean by saying angle in the same segment. Angle in the same segment in simple English simply means two or more angles that are sharing the same chord as their base. So since angle D, this angle D has enabled me to what? To know the chord upon which, now we've gotten the chord upon which this angle D is resting. We know that is AB. Now let's see from this AB, do we have any other angle in the circumference? Now when we consider the diagram we have here, so we can see there are two angles in the circumference. This is one, this is one. Now the other angle we want to verify whether it is the same chord as this one is. So what we are going to do is we go to that angle in the circumference now. That's angle C. So what we are going to do is we want to determine we consider this line as this one as well as this one as two separate lines. Now from this side here, so I will take this place that I call my angle. This is going to be considered as the top of this line, while the place where it stops here is going to be considered as its what? As its base. So for the other line I have here, this place here, the position, the line here, the upper place here, I will refer to it as what? As my top. While this place here as well is going to be referred to as my what? As my base. Now when I now join the base for this line here, as well as the base for the second line here, let's join the two. So when the two is joined, so we can see it also give a line named AB, or what we can also call chord AB. So we can see that the base of the triangle which we have now is the same thing. The base of this triangle now is the same as the base which this first triangle here has. So since both are resting on this common chord AB, so then we say that what? Angle D as well as angle C are in the same segment. And geometrically, when any two or more angles are resting on the same base, they are resting on the same chord, their value automatically becomes the same thing. So angle D is equal to what? Angle C. That is what the theorem is saying. Now we've been able to know how do we determine angle in what? In semicircle, as well as how do we find angle in the same segment. So once we've been able to achieve this, then applying the theorem into solving questions now becomes very easy. So what we now do is we begin solving questions. Now, in my example 1, I have this diagram. Now, the requirement in number 1 is this: we have to find QNN. That is, we have to find angle N. The mean angle is what we are interested in. So that is, we have to find QNN. So this is angle N that we have to find. We can name it, we can give it a name theta or X or any other angle measurement. Now, that's the first thing that we have. Now, we've talked about 3 theorems so far. So we have to start thinking, which of the theorem can we apply first? Now, the first theorem we treated was the one which we talked about in the last class. So which was the one we stated that what? Angle at the center is twice the angle at the circumference. So now let's go straight to the center to see whether that theorem can be useful in solving this question here. Now, when we observe, when we look at this thing very well, so we can see this is the center of this circle. And by the nature of the diagram that we have in this very question, we can see that no angle is formed at this center at all. Since no angle is formed at this center at all, no point in talking about or in thinking about making use of what the theorem states that angle at the center is twice the angle at the circumference. There is only one condition for making use of the theorem. The only condition for using it is when angle is formed at the center of the circle. So since no angle is formed at the center, so you should just forget about that theorem. That theorem is of no use in this scenario. Now the next thing is we think of other theorems which you have learned. And that's the theorem which talks about what? Angle in what? In a semicircle. So remember, to talk about angle in a semicircle, diameter has to be given. What is a diameter? It is a line that passes through what? The center of the circle. And when we look at this circle very well, we can see this center O is the dot. This is the center here. So and we can see a line touches it, passes through it, which is this line. We can see the way this line moves. It moves from up down like this. And in the process of this line moving, it moves over what? Over this our center. The point we use to what? Indicate the center. Since that one passes through the point, so it shows the theorem which states that angle in a semicircle is right angle is going to be what? Applied in this scenario. So to doing it, what do we do? What does it mean? So we need to identify our semicircle, to identify our diameter. So just like I've just talked about it, the line that moves from here to this point, that is the line that touches this center here, is our diameter. So since we have diameter, then the next thing is to pick its two endpoints. So what are the two endpoints? The point where this line touches circumference here, where it touches the circle here, as well as it touches the circle here. So these are the two endpoints. So this endpoint is marked with what? Letter P and letter Q. Now, to form an angle in the circumference depends on the movement, how the diagram is structured. So we can see that from these two endpoints here, another line was drawn. So the line drawn here moved into this direction and not into this direction. So which means semicircle in this area is going to be towards this area and not into this area. Reason being that no line is constructed from here to anywhere in the circumference here, and as well as here, a line is drawn from here, but no line is drawn from here to join it. So when we want to talk about angle in the semicircle, it has to be that area where what? A line was drawn from the end point here as well as from the end point here, and not only that, the two later words collide here. So what we are now going to do is we want to form the angle to determine where is the circumference. So to determine the angle at the circumference now, we come to these two endpoints. So from here I move down here, and from here I move with the aim of what? Ensuring that the movement here touches my earlier movement. So which means this line here, the two meet at this point M, and the angle M, the whole angle M is movement from here to here. And this one has the value of what? 90 degrees. Since the theorem states that angle in a semicircle is a right angle, that is, angle in a semicircle is 90 degrees. So that is a 90 degree there. Now what follows it? We have to find theta. So we know we've not talked about finding our theta. Now the next thing is, it is advisable at times when dealing with this aspect of geometry. So to always, when we have a triangle at time, to quickly solve what we have inside our triangle before we progress into applying the next one. So what we just did now, so we can see that this is a triangle. Since this thing is a triangle, remember triangle always has three angles. This is one angle, this is one angle, this is another angle. So two of the angle is known already. So it is better we find the third angle. So because the value here might be useful, it might be something that will assist us in getting what we are asked to do. So as a result of that, what we are going to do is we are going to consider this triangle PQM and solve it. So since two of its angle is given, so we can try and determine what? The last angle. So doing that will become 63 degree plus 90 degree plus, we can call it just P, or we can call it QPM. And that is the best way to state our angle. We say QPM is equal to 180 degrees. So the reason for this is what? Sum of angle in a triangle is what? 180 degrees. And when added together, I have 153 degrees plus QPM is equal to what? 180 degrees. So getting my QPM here means I will have to collect the like terms. So that is QPM is equal to 180 degree minus 153 degree, and that gives the value of what? 27 degree. So, and it is advisable whenever we get a value that we always what? State it in our diagram, so to make what we want to do very clear. So since that is 27, so my 27 degree will be recorded or will be written there. Now I can now think of what I'm asked to do. I'm asked to find angle Q. Remember, we have learned so far 3 theorems. So far so good to us. To this class, we want to assume only 3 theorems exist. So far so good. I'm not saying that is not the theorem that exists in dealing with what? Circle geometry, but for now, only 3 theorems exist to us because of our level. Now, first theorem is of no use here. That's the one of center and circumference. Second theorem is the one which talks about what? Angle in semicircle. We have used it. So it means we have one more option. So the last option we have is the one which talks about what? Angle in the same segment. Now let us try whether that will be of help in determining the value of our theta. And to using that theorem, so what we need is, we'll consider one of the two angles. So what we really need to do in applying that theorem is to go and verify what is the base of this angle theta here, or from what chord is this angle resting. So what I will do is, since this angle is what I want to verify, I want to verify its base. So what I will do is, two lines that form this angle are this line as well as this line. So what I will do with this line is, from here I will keep moving until I reached circle. I reached the point on circle. So one of the way I can do that is I keep drawing a straight line. So this line will keep moving like this. So when we get here, we will not stop here because this is just a line. It is not circle. It is not a point on the circle. So we won't stop here. We will continue moving until we reach here. So we can see at this point, this is a point on circle. So we are going to stop here. That's the movement from here down there. And movement from here as well. So the movement will have to be like this. So it means this angle has two base. Has a base. So the base has 2 points. So the points are Q and M. So it means that what? This angle theta is resting on chord QM. Now the next thing we are going to do is, let's pick any other angle we have at the circumference. Or is there any other angle that is resting on what? On this chord QM, which I have here. So this is Q here, this is M here. Now let's say from here I move here, and from here I move. So we can see that this angle, which we call 27 degree, is also resting on this chord QM. So since it is resting on chord QM, it automatically means both this angle P as well as this angle N, they are sharing the same chord. They are both resting, lying on the same chord QM, and as a result, their angles are going to be equal. So that means that this theta, or what we call QNM here, is equal to this angle here, the angle P, but the best way to name it is to call it QPM, is equal to QPM. And by theorem, so if we are told we need to state the theorem, that is to say that what? Angle in the same segments are equal. So we can now say that QNM is equal to, what do we have at QPM? That is 27 degrees. So what we have to find in this case 1, in the first question, is what? Is 27 degrees. So, and this is the what? Complete solution to our first question. So right now move over to the second question. So in number 2, suppose this is the center. Okay, let me draw the diagram first before the explanation. So this is y. Now in this case here, we are asked to find two unknown. So the two unknown which we are asked to find are the x as well as y. Now dealing with circle geometry simply means applying those theorems. Now we've learned so far so good 3 theorems. So we start thinking which of the 3 theorems can we apply first. So I think we should start with the first theorem which we learned in this class. So the first theorem was the one which states that which talks about angle at the center as well as the angle at the circumference. That is, angle at the center is twice the angle at the circumference. Now, but that theorem will only be useful whenever angle at the center is given. That is, whenever angle is formed at the center. That's when we think of applying the theorem. So we can see this is the center of this circle. No angle is formed there at all. The only thing we see at the center is straight line. So it shows the theorem 1 cannot be what? Useful in this case. Now let's think of the second theorem. So the second theorem is the one which talks about what? Angle in a semicircle. So do we really have semicircle in this situation? And to talk about angle in a semicircle, we must have what we call what? A diameter. And what is a diameter? It is that line that straight line that passes through the what? The center of our circle. We can see this in this circle. The center of the circle is this point. And we can see a straight line that passes through it, that go over this line. So that straight line is what we call the diameter. So once we have such a line, then the next thing is two endpoints. We want to verify where does it meet elsewhere on what? On the circumference of the circle. Now, so this is one endpoint here. If I want, I can name it A. Second endpoint, I can name it B. Now what I would now love to do is, from this point A here, I want to move to the circumference. We can see from this point there are 3 movements to the circumference. Here is one movement, here is one movement, and here is another movement. But which of these 3 movements is going to be useful to us? It is only movement that will permit the movement from this point to what? To form another point on the circumference of the circle, which will now lead to what? Formation of angle. Now we can see that of 1, 2, 3. So okay, well, let me go back to the other endpoints here. So from this endpoint, there is a line that moves from here down to this place. So we can see this line forms an angle with the one moving from here, and not this one or this. So it means this is the point that we want towards the theorem is talking about. So the theorem will now be talking about this straight line versus this straight line. So the theorem states that what? Angle in semicircle. So this angle we have here is the angle which faces a line that turns this circle into what? To a semicircle. So automatically, this is the angle in a semicircle. And by the theorem, we are told that angle in a semicircle is a right angle. That this angle in a semicircle is 90 degrees. So it shows this y has the value of what? 90 degrees. So we can put it here, y is equal to 90 degrees. What's the reason for that? We say that what? Angles in a semicircle is 90 degrees. It's a right angle. In short, I can just say it's what? It's 90 degrees. So that's that. Now the next thing is we want to determine the value of y. So we can say the only area where angle in the semicircle can work is this case where we have used it, and that is all it can do. Then the next theorem which we know is the one which talks about what? Angle in the same segment. Now, so to do that, all we are going to do is let's go and pick the angle which we are asked to find now. So we want to know on what chord is it resting, or what is the base of its angle. So we are asked to find this angle x. We want to find this angle x. So what we do is we want to find its base, the base of this angle here. So to find the base of this angle here, what we do is we can see that this point that lead into this angle has 2 lines. So a line that moves this way as well as a line that moves in this direction. So what I want to do is I will keep moving from this point until what? I reach another point on the circle. So the movement will keep moving. Remember, we are not going to stop here because the intersection here is not on circles, on another straight line. We want the one that's going to be on what? It has to hit that circle, the body of the circle. So the line will keep moving like this until we get here. So this is one of the points which we are looking for. Then the other one is the movement that goes this way. So that one we also keep moving until we reach this place. Now we will now try to do what? To connect this point to this point. How do I connect this point? Is it by saying this to this? So we can see here to here without giving this point. So it is only when I move from here down here that will give me this point. So it shows that what? This angle which I have here, this angle x here is resting on chord A. We can name this one C. It is resting on chord